Hi everyone, I'm Michael and welcome back to another video. So I will be explaining problem number 4 from the Washington Gold HMMT PUMaC team selection test. So the problem goes as follows. So we have x1, x2, x3, and x4, and they're the roots of the polynomial x to the 4 minus 3x cubed plus 7x squared plus 15 equals 0. And we want to find this sum. So the sum is created by, it's the sum of x sub I cubed times x sub j times x sub k, and the sum is taken over all pairwise distinct indices I, j, k from 1 to 4, such that j is less than k. Alright, so that can be a lot to take in. So when I am encountered with a scary notational sum like this, what I like to do is I just like to write out what the sum actually means. And actually, in this case, it's really good to write out the sum in terms of I. So to get what I mean, let's just write this out. So we know that I can range from 1 to 4. 1 is less than or equal to I is less than or equal to 4. So this sum, the sum of x sub I cubed, x sub j, x sub k is equal to the sum of x1 cubed, xj, xk plus the sum of x, let me just put that in the subscript part, plus the sum of x2 cubed, xj, xk plus the sum of x3 cubed, xj, xk, and let's scroll over a bit, plus the sum of x4 cubed, xj, xk. Great, so we have this sum in a slightly friendlier setting. I mean, it doesn't look friendlier now, but it will in a bit. So this still has a bit of notation to it. So let's just zoom in our focus to one of these smaller sums, okay? Let's just look at one of these smaller sums. So what are we summing over? We're summing over all indices such that j is less than k, and j and k are distinct from I. So that means in this sum, j and k are not 1. So we can see that this actually collapses into this sum. This collapses into x1 cubed times x2 times x3 plus x1 cubed times x2 times x4 plus x1 cubed times x3 times x4. And now we see what's so great about this, because we can factor out the x1 cubed, right? So this is what the first sum here becomes. x2, x4 plus x3, x4. And by this point, we should really be thinking about Vieta's formulas, because we have all the symmetric sums, because we know, let me just zoom back in. We know what polynomial x1, x2, x3, and x4 are the roots of. So we have all the symmetric sums in terms of x1, x2, x3, and x4. And here, we have this inner part right here. We have this part. It is a symmetric sum, but unfortunately it's only a symmetric sum in terms of x2, x3, and x4. There's no x1 involved. But we'd really like to get an x1 involved. So here's what we're going to do. We're going to use the fact that this looks a lot like the second symmetric sum, except only without the x1 terms. So what is the second symmetric sum in the variables x1, x2, x3, and x4? This is equal to x1, x2 plus x1, x3 plus x1, x4 plus x2, x3 plus x2, x4 plus x3, x4. And from Vieta's formulas, we know that this sum, this second symmetric sum here, has a value of 7, because this is just the coefficient of the x squared term divided by the coefficient of the x to the 4 term. So this sum, we know it's 7. Alright. But now, notice that we have this part. This part is exactly the same as the thing we had in here. So we can just substitute this back in to get this sum is equal to x1 cubed times 7 minus x1, x2 minus x1, x3 minus x1, x4. And we can factor out the x1. And we can just expand real quick. x2 plus x3 plus x4. So this is just by expansion. Alright, and, well, we have so many things in terms of x1 at this point, and alarm bells should be going off because we realize that we can just do the same thing here. Because by Vieta's formulas, we already know what x1 plus x2 plus x3 plus x4 is, right? By Vieta's formulas, this is just the negative of the coefficient of the x cubed term divided by the coefficient of the x to the 4 term, which is equal to 3. So we know that this is equal to 3. So that means this sum is equal to 7 times x sub 1 cubed minus x1 to the 4 times 7, not 7, 3 minus x1. And we have everything in terms of x1. So it turns out that this really scary sum here is just equal to that. Alright, so when we expand, we can get that this is equal to 7 x1 cubed minus 3 x1 4 plus x1 5. Cool. So this sum, the first part of this sum where I equals 1, is just this thing. And similarly, we can write the other sums in this way too. So that means this entire sum is equal to x to the 1 fifth plus x2 to the 5th plus x3 to the 5th plus x4 to the 5th, right? Minus 3 times the sum of the xi to the 4 plus 7 times the sum of xi cubed. Great. Alright, so instead of the scary sum that we had to compute at the beginning, we just have to compute this sum, which might seem also to be a bit scary, but at least we have everything in terms of these neat symmetric power sums. Alright, so what do we do now? Well, what's bugging the most here is these fifth powers. These fifth powers are really annoying because it doesn't seem like you can compute them easily. But remember what we have here. We have that x1, x2, x3, and x4 are the roots of this polynomial. So let me just erase the arrow so you can see it more clearly. We have it that they are the roots of this polynomial. So what does this mean? So we know that for x1, x2, x3, and x4, we actually have this equation. Plus 7x squared plus 15 equals 0. So what does this mean? This means that if we rearrange this, we know that x to the 4 equals 3x cubed minus 7x squared minus 15. And if we multiply by x, we get that for x1, x2, x3, and x4, x to the 5th equals 3x to the 4 minus 7x cubed minus 15x. And this is where it all pays off, because x1 to the 5th with this equation is equal to 3x1 to the 4 minus 7x1 to the cubed minus 15x1. So now, using this equation, you can just watch the cancellation happen. x1 to the 5th plus x2 to the 5th plus x3 to the 5 plus x4 to the 5 is equal to 3 times x1 plus x2 plus x3. Sorry, these should have fourth powers on them. So x1 to the 4 plus x2 to the 4 plus x3 to the 4 plus x4 to the 4 minus 7 times x1 cubed plus x2 cubed plus x3 cubed plus x4 cubed minus 15 times x1 plus x2 plus x3 plus x4. And now what we want to do is we want to find this expression. We want to find this expression. So this, we can have everything cancel out. That means this minus, so that means this quantity, you have this quantity minus 3 times x1 to the 4 plus x2 to the 4 plus x3 to the 4 plus x4 to the 4. That cancels out with this. So this term just goes away. And we have a plus 7 times the sum of the variables cubed. We have a minus 7. These two terms go away. And now the only thing we have to evaluate, the whole sum, is we just want to find this. And we know from Vieta's formulas already, we derived it before, that x1 plus x2 plus x3 plus x4 equals 3. So negative 15 times x1 plus x2 plus x3 plus x4, which is our answer, is negative 45. And we're done. Now that might seem a bit long-winded, but with practice, it gets a lot faster, and the solution is not nearly as scary as it might seem at first.